Hello all, myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we are going to discuss about language translators. So language in the sense programming language translators. So in this language translators, we have assembler, compiler, and we are going to talk about assembler, compiler, and interpreter. So first, let us see why we require this language translators. And first, let us see the evolution of computer languages. So generally, to write a program for a computer, so we need to use computer language. So computer understands the language of binary, that is zeros and ones. So in order to store the data, in order to process the data, it requires the data in binary form, that is zeros and ones. So over the years, computer languages, they have evolved from machine languages to natural language. So this is how you can list the evolution of languages or computer languages. So in 1940s, machine languages came into existence. Machine languages were developed. Next, after that, in the year 1950s, symbolic languages were developed, so which were more easier than machine languages. Then after that, in the year 1960s, high-level languages, they came into existence. So these were more user-friendly, or the humans can read it or understand it more easily as compared to symbolic or machine languages. Now let us see the features of this. In the earliest days of computer, so only program language which was available is machine language. So computer understands the language machine language, that is zeros and which is made of streams of zeros and ones. So this is also referred to as binary digit. So these are so named as because the machine can directly understand the programs. So anything which is written in zeros and ones, machine language is so named because the machine can directly understand the program. So therefore it is called as machine language. Next, in the year early 1950s, Admiral Grace Hopper, he was a famous mathematician and naval officer. He developed the concept of special computer program that convert programs into machine language. So these early programming languages, they simply mirrored the machine languages using symbols or mnemonics to represent the various language instructions. The next evolution of languages was symbolic language. So in symbolic language, or symbols or mnemonics were used to represent the various language instructions. So these they are known as symbolic languages or mnemonics, because in this language symbols were used. So therefore it was called as symbolic language. So a special program called as assembler, it translates the symbolic code into machine language. So there is a special program called as assembler, so which translates the symbolic code into machine language. So symbolic languages, they greatly improve programming efficiency, but it still required the programmers to concentrate on the hardware so that they were using. So working with symbolic languages was also very tedious because each machine instruction has to be individually coded. So the desire to improve programmer efficiency and to change the focus from computer to problems being solved. So this is the main important criteria for the evolution of languages. First, machine language came into existence. First, machine languages were developed. Then after that, symbolic language were developed. And then after that, high-level languages were developed. So to change the focus from computer to problems which are being solved, and also to improve the programmer efficiency. So these factors led to the development of high-level languages. So high-level languages, these are portable to many different computers, allowing the programmers to concentrate on the application problem at hand rather than the intricacies of the computer. So when we are writing the program in machine language, the programmer has to take into consideration the hardware also, intricacies of the computer also. So whereas in case of symbolic also, this was somewhat easier than machine language, but even then it was also in this language also, the intricacies of the computer had to be taken into consideration. But this was resolved by using high-level languages. So a program which is written in assembly language as well as high level language. So they need some software or language translators which convert the source code to machine code. So a program can be written in assembly language as well as in high level language. So this written program is called as source program or source code, you can say. Source code, generally we use the word source code or source program. So this is nothing but the program which is written in assembly language or high level language. So this source program is to be converted to machine language. So in order to get the output so that the machine can process the program or the data which is given by the user, so it has to be converted to machine language. The program has to be converted to machine language. So for that purpose we have translators, language translators. A language translator, a programming language translator is required for such translation. So in order to convert the language, that is human readable language, to machine language, we have translators. So program translator, it translates the source code of the programming language into machine language instruction code. So that is the main purpose of translator. It is also a program which translates the source code of the programming language into machine language instruction code. So in this way we have translators, three types of translators we have: assembler, compiler and interpreter. So we are going to discuss in detail about assembler, compiler and then interpreter. So there are programs which are used for converting the programs in one language to machine language instructions so that they can be executed by the computer. So coming to compiler, so we can say that it is a program which is used to convert high level language program to machine language. So assembler is a program which is used to convert assembly level language programs to machine language. So interpreter, it is also a program which takes one statement of, it also converts high level language to machine language. So it takes, but the way of converting to machine language is different for compiler and interpreter. So that we'll see in detail. So interpreter is a program which takes one statement of high level language program, translates it into machine language instructions. So in language translators we have three types of translators: compiler, assembler and interpreter. Based on the input, what it is taking, what type of language it takes. So based on that we have three types of compilers. So assembler takes input in the form of assembly language. So it takes assembly language code and then it converts it to machine language. Whereas compiler and interpreter, so for them the input is or the source is high level language programs and then they convert it to machine language. But the way of converting machine language is different for a compiler and an interpreter. Now let us see compiler, assembler and interpreter in detail. So this is how you can understand a compiler. Assembler. So assembler is nothing but it is a program which converts mnemonic language or symbolic language. So we have seen that symbolic language. So we call it as symbolic language. Why? Because symbols are used here. So for example, MOV, move. So in order to transfer, we have move commands. Next we have SUB for subtraction. We have ADD for addition. The symbols are used here in this language. Therefore, we call it as symbolic language. Assembler converts mnemonic language to machine code. So the program is in alphanumeric symbols. So instead of zeros and ones, in machine language, the program was in terms of zeros and ones. Whereas in symbolic language, it is more user-friendly and it is in alphanumeric symbols. So designer chooses easy symbols which are to be remembered by the programmer so that the programs can easily be developed the program in assembly language. So alphanumeric symbols, so these are called as mnemonics in assembly language. For example, ADD is used for addition, SUB is used for subtraction, MUL is used for multiplication, DIV, RLC, RAL. These are some of the symbols which are called as mnemonics. Next, after this we have compiler. So compiler, the source program is input to the compiler here. So which is written in high level language. So output for this is the object code or machine code, you can say. So this is the output for the secondary storage device. So entire program will be read by the compiler first and generate the object code. So compiler purpose is to generate it takes high level language as the input. So instructions are given in high level language, and then it gives the output or object code, converts it to machine code. So before converting it to machine code, so it is compiled first. So compiler, it generates an intermediate object code, so which cannot be directly, it generates an intermediate object code, and then after that, so entire program will see the difference between compiler and interpreter. So compiler also translates high level language program to machine language. So but the way of doing is different in compiler and interpreter. So entire program is read by the compiler first and generates the object code. So compiler displays the list of errors and warnings for the statements violating the syntax rules of the language. So example, we have C compiler we have. Next we have interpreter. Interpreter is a program which directly executes the instructions in high level language without converting it into machine code. So that means, so while it takes one line at a time, so interpreter, it takes one line at a time, converts into machine code, and then runs the same code. So interpreter directly executes the instructions written in programming or scripting language without previously converting them to an object code or machine code. So let us see the differences between compiler and interpreter. So compiler takes the entire program as input, whereas interpreter takes single line instruction as the input. So here intermediate object code is generated here, but here in this case no intermediate object code is generated. So here for this, compiler requires more memory because intermediate object code is generated and that is stored in secondary storage device. For this, more memory is required here. Whereas for interpreter, it does not generate any intermediate object code, so memory requirement is less here. So here program need not be compiled every time, but in this case, every time higher level program is converted to high level program is converted to low level program. So here errors are displayed after entire program is checked, but here errors are displayed for every instruction which is interpreted. So these are some of the differences between compiler and interpreter. So thus in this video lecture, we have seen the different types of language translators which are available. First one which we have seen is assembler, next one is compiler, and the last one is interpreter. So thus in this video lecture, we have seen some of the basic concepts of C programming. In the next video lecture, we will see some more concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.